Oh, here we go. Right, we're recording. C3 Homework this week. What are you doing?
It's at an angle.
It's trigonometry homework, and it's the a sine b, a sine theta plus b cos theta stuff. Yeah, all of that thing. Right. Express. I'm being blinded. Express 8 sine theta minus 6 cos theta in the form r sine theta minus alpha, where r is greater than 0 and theta alpha is between 0 and 90. It's the standard kind of start to this question, and we're told the form to use. So remember what we do. We write this, and then we expand r sine theta minus alpha using the formula in the formula booklet. It becomes r sine theta cos alpha, and it's a minus, so we minus equals r cos theta sine alpha. That's the sine a plus b.
Sorry.
And then if we compare the things that are the same there, we've got sine theta there and sine theta there. So that means that 8 must be equal to r cos alpha. We've got a cos theta there and cos theta over there.
I'm taking blue now.
So that means that r sine alpha must be 6.
Why have you got -6?
We've got a minus on both sides, haven't we? So you could write -6 equals minus r sine alpha.
No, she just got it wrong.
Well, I got the answer right though.
Suspicious. If we now square these and add these together, we'd get r squared equals 8 squared plus 6 squared. That gives us r squared is, well, that's 64 plus 36, we've got 100, so r is 10. Remember, we take the positive one because r is greater than 0. Sub that back into our two equations, and they give us cos alpha would be 8 over 10.
It's a good job you didn't use
They also give us sine alpha would be 6 over 10. We're making sure that we agree with these, that the two give us the same angle. It gives us the value of alpha would be, so what have we got for that? 36.9. Okay, so we're saying that 8 sine theta minus 6 cos theta is 10 sine theta minus 36.9 degrees. We were working in degrees because we were given alpha in degrees there. Brilliant, that was 3 marks. Hence, solve for theta in the range 0 to 360, the equation, that equals 9. So that's what we started with, isn't it? So we're really saying that 10 sine theta minus 36.7. 36.9, sorry. Is equal to 9. So we're going to rearrange that. Sine of theta minus 36.9 is 0.9. We're going to do inverse sine of this to get our first value. Have we got inverse sine of that then? We seem to have a figure of 64.16. Is that? Do we agree with that? So now we'll go to the cat diagram, or however we want to do this. Climb a small tree. That would work. And there we've got 64.16. And the other one would be over here, wouldn't it? Because it was sine and it was positive. 64.16. So our second value is what?
You can just see James and your arm.
Right. Our second value is going to be 180 minus that, which is, 100. 115 point something. What did you get?
8.
0.8. Oh, very good. And now to get theta, we're going to add 36.9 to both of these to give us our values, which were 101 degrees and 153 degrees to 3 second figures. Good job. Right. That was 4 marks, was it? Or was that 3 again? 4 marks for that. Brilliant. And part B, find the greatest possible value of this thing here as the angles x and y vary. Right, well let's think about what this thing is. 32 sine x minus 24 cos x. That was part 2. So that was part 1, wasn't it? That was A, part 1. What was the question? 32 sine x. Right. Yeah, done. Okay, so we need to simplify this and get this in terms of what we want. And we've got, well, hang on, we were working to start with 8 sine theta minus 6 cos theta. So let's try and relate it to that. We've got a common factor in here. If we take out a common factor of 4, then this becomes 4 lots of 8 sine x minus 6 cos x. And here, if we take out a common factor of 2, this becomes 2 lots of 8 sine y minus 6 cos y. And at this point, once we see it like this, we're beginning to feel quite kind of warm and cosy about how this is looking. So, it's 4 times 10 sine x minus 36.9 in there. And this one is minus 2 times 10 sine y minus 36.9. That's quite neat, isn't it? So what we really are meaning with this is that this thing that we started with is the same as 40 sine x minus 36.9 minus 20 sine y minus 36.9. Now, as x and y vary, this will take different values, won't it? And we wanted to find the greatest possible value of it. Well, as x varies, sine of this function goes between minus 1 and plus 1. So this bit is varying between plus 40 and minus 40. At the same time, y is varying, and this bit is going between plus and minus 1, so this bit between 20 and minus 20 that we're subtracting. So if we think about the biggest value that this could possibly take, we weren't asked for the values of x and y, we just asked for the value. So the greatest value would be when sine of x minus 36.9 equals plus 1, which makes that 40, and when sine y minus 36.9 is equal to minus 1, because that means we'd be taking away 20 lots of minus 1, which would give us a greatest value of 60. That, and there is your final answer for 3 marks, and that's maths.